Binomial expansion. Here shown is the binomial theorem. Luckily for you, this is going to be given to you in your formula book in the Core 2 exam. Now, this formula looks quite horrific, but it's very easy to use. So it's used to calculate what a plus b to the power of n is when expanded. Now, I'm just going to give you a couple of seconds to look at what's happening in the rule. In particular, look at what's happening to the powers of the a's from the left to the right, and look what's happening to the power of the b's. Hopefully what you've spotted is that the powers of a start off at a to the power of n and gradually make their way down towards the end when you've got a to the power of 0, which is 1. So a to the power of n and a to the power of n minus 1, and as you go along towards the end you've got just a because it's a to the power of 1, and there's nothing on the last bit because as I said it's equal to 1. Likewise, if you look at the b's, the first one you've not got any b, but you've got a b, then a b squared, then at the very end you've got b to the power of n minus 1, and finally you've got b to the power of n. The bit that's a little bit more difficult is these n0, n1, n2, n over n minus 1. Well, these are from what we just looked at when we looked at combinations and factorials. Well, they are combinations, so xy means you're picking x items from a possible y. So n0 means you've got n possible items, but you're taking none of them in any order. Likewise, the second one, you're taking one in any order of the possible n available. So you're asked to use the binomial theorem to find the expansion of this 2x minus 3 to the power of 4. Now, the first thing we want to do is we're going to write out all the parts of the formula. So we'll use the a as the 2x and the b as the minus 3. Remember to take that power with you as you're going through this problem. So the n here is 4, 0, and we've got the 2x to the power of 4. Next one we want 4, 1, where 2x to the power of 3 times by minus 3. Next one 4, 2, and we want 2x squared, and we want minus 3 squared. Next one is going to be 4, 3, 2x and minus 3 to the power of 3, and finally 4, 4, we've got no 2x anymore, minus 3 to the power of 4. So what you should notice from what I've just done is that the power of the 2x has gradually gone down every time, and the power of the minus 3 has gone up by 1 every time. Now, 4, 0 comes from our combinations from before, so remember 4 factorial is equal to n minus r, which is going to be 4 factorial times 0 factorial. Remember 0 factorial is 1, but that bit all gives us 1. If we looked at the next one, you'd have 4 factorial divided by 3 factorial times 1 factorial, which is equal to 24 divided by 6, which is 4. Now you could go through and do each of those by hand. However, remember on your calculator, just above your divide sign, you have the word NCR, and you can use that button to calculate these values really quickly. And if you do that, you'll find that these values come out as being 1, 4, 6, 4 and 1 again. Now those numbers happen to be the numbers that we discovered in the Pascal's triangle in an earlier video. That's why I said it'd be very useful, the Pascal's triangle, when looking at binomial theorem. Now if we take those numbers and we sort out the rest of it. So the first one we're going to sort out, we're going to do 2 to the power of 4, which is 16, times by 1 is 16. We're going to get 16x to the power of 4. If we do minus 3 times 2 cubed times 4, we get minus 96 to the power of x cubed. If we do the next one, which is minus 3 squared times 2 squared times 6, you get plus 216 x squared. Do the next one, you get minus 216x, and finally you get 81. And that is the binomial expansion for our original question, which was 2x minus 3 all to the power of 4. As I said, you do not have to learn the binomial theorem, as it is given to you in your formula book.